Okay, dear friends, today we have a session on integral calculus as a part of the online problem solving session series organized by Maths Aspirants groups. This is actually in continuation with the previous session, selected problems from integral calculus part 1. Now, today's resource person, Krishna Misra from IIT Kanpur, will continue his discussion on problems from integral calculus. Mr. Krishna did his M.Sc from Cotton University, Guwahati, Assam, and currently pursuing M.Tech in IIT Kanpur. I hope that today's session will be really helpful in your preparations for examinations like JAM, NET, GATE, etc. Krishna will present problems from the previous question papers of these exams with you. And at the end, there will be an interactive session. So I request all the participants to be actively present in the class and try to respond to the questions raised by Krishna. And once again, I would like to thank Krishna for joining with us. I hope that today's session will be really a very wonderful session. Wish you all the success. Welcome everyone again to this program. Welcome, Krishna.
Thank you so much, sir, for the nice and beautiful introduction. And everyone who has joined us this morning for the second problem session on integral calculus. Welcome you all again.
So the first question that I have chosen is it was asked in Jan 2020. I think it was from Maths, I think. So it's a the idea about today's preparation is we will just be covering the problems from topics in integral calculus because in the last session we covered all the theory and everything required for the syllabus. So today I won't be covering any theory. I'll just be covering the problems. So that's what we are going to do today. The first problem is this one. Double integral e to the power x squared dx dy. The limits are this equal to k times e to the power 4 minus 1. Then what is the value of k? That is what we are asked. So notice that the function that we are going to integrate is e to the power x squared. Right? So if you recall the problems in integration, you will realize that e to the power x squared is not an easy function to integrate. And as for example, if you are given something like this, e to the power x squared dx, that is not easy to integrate, right? So what we will do here is we will change the order of integration so that our task becomes very much easier. So the question is this: e to the power x squared dx dy. X goes from twice y to 2, y goes from 0 to 1. X goes from twice y to 2, y goes from 0 to 1. Now let's take a look at what the limits represent. Look at the inner integral dx. X goes from twice y to 2. So x equal to twice y is this line. If you look at the first picture here, x equal to twice y is this line. Okay, and the upper limit of the inner integral is x equal to 2. So x equal to 2 is this. So x goes from twice y to 2, from here to here, for the bound of x. Next, for the limits of y, y goes from 0 to 1. So y goes from y equal to 0 up to y equal to 1 that I have drawn here. So you are going to integrate this function e to the power x squared precisely over this shaded area, right? Now we have seen that we can't do this directly. So we want to change the order of this integration. How do we do that? The changing order simply means we want to integrate with respect to y first, because it was dx dy. We just have to change the order. It will be dy dx, the limits of y and then limits of x. Now this is the area that we want to integrate over. This one. So precisely this area that I've drawn here again. Now we want to cover we want to give the bound for y first, because we are trying to change the order, right? So y goes from y equal to 0 up to this line. This line was x equal to twice y at first. So this line was x equal to twice y. It's the same as y equal to x by 2. So the limits of y are y from 0 to x by 2, and the limits of x will be from 0 up to this one, x equal to 2, right? So that is how you can cover the entire region as well. So x from 0 to 2. This was covered in the last session, but I didn't have much time, so I did it only in 5 minutes. But that is how we actually change the order of integration. It was dx dy first. Now we are doing dy dx. So because the inner integral is a function of x, and you're trying to integrate with respect to y, so it's very easy now. So it will be x goes from 0 to 2. You can pull out the e over x squared, and the inner integral is nothing but x by 2 if you do it, and there is one dx. So it is e to the power x squared into x by 2. So if you do the substitution, x squared equal to t and all those things, then you can easily do this integral. That is very easy now, and the answer will be something like 1 by 4 e to the power 4 minus 1. So if you compare this to what was given in the question, it was k times of e to the power 4 minus 1. So our k will be this one, right? Our k is 1 by 4, and that is nothing but 0.25. Is it clear, guys, how we tried this problem? Guys, is it clear, or do you want me to repeat this solution again?
Yes, sir.
Clear? Okay. So let's move to the next problem then. So yeah, the main idea is that if you get a function something like this, which is hard to integrate, then maybe try to change the order of the integration. And when you're trying to change the order, make sure that you are putting the limits correctly, because the previous limits were this. Now I have changed the limits. So that is the only thing you have to be careful about when you are doing something like this. Okay, let me go to the next problem then. So it was asked in JAM 2019 mathematics. So the value of the integral, if you read the question, it will be something like this. The value of this integral is what? That is our question. Now, how would you guys approach this problem? That is something that I would like to ask. Can you guys tell me? Any idea? Any hunch how you'd like to approach this problem? I've drawn just the diagram just to be to make it easier for you. Guys, anyone? Okay, let's try this problem. Look at the question. You want to integrate the function y sine pi 1 minus x whole thing squared over the region given by the limits, right? So I have drawn the region. X lies between 0. Look at the inner integral. X lies between 0 and y squared. So x lies between, this is x equal to 0, so this line, and sorry, x equal to 0, and x equal to 1 minus y squared, because the function is y sine pi 1 minus x squared dx dy. X lies between 0 and 1 minus y squared. So this is the upper limit of the inner integral. So x equal to 1 minus y squared. I have drawn this function here. X equal to 1 minus y squared, this one. So x lies between x equal to 0 and x equal to 1 minus y squared. So like this. And the limits of y are y equal to 0 to 1, right? Y equal to 0 up to 1. So it will be y equal to 0 is this, and y equal to 1 is this one. So precisely you have to cover this region when you integrate this region. Okay. Now if you note again, like the last problem, you will see that this is not an easy function to integrate with respect to x. Like you could try, but it will be lengthy task for you. And in exam, that is not very much recommended to do so much of hard work. So what we can do is we can try to change the order again. So it was the inner integral, the inner variable was x and then y, right? Dx dy. So maybe try to change the order of this integration. So I'll just write like this. The function remains the same. There is no change in the function. All you have to do is just change the order. Dx dy was, it will become dy dx now. So where the limits of y will come first and the limits of x will come later on. So the limits of y would be, if you look at the second picture here, the limits of y is, y goes from y equal to 0 up to this curve, right? So y goes from 0 up to this curve. This curve was x equal to 1 minus y squared. This you can also write it as y equal to positive square root of 1 minus x, I think. So y goes from 0 to square root of 1 minus x. Y goes from 0 to square root of 1 minus x. And the limits of x would be x equal to from 0 up to x equal to 1. So that is how you cover the entire region again. So x from 0 to 1. And with this change of order, what you can do is x goes from 0 to 1. If you try to integrate this now, you can pull out the whole function of x because you are trying to integrate with respect to y. So I can pull out sine pi 1 minus x whole thing squared, and only y remains. If you integrate, it will be y squared by 2. So it will be 1 minus x by 2 dx. Now it is very easy because you can substitute pi 1 minus x. Now if you do the substitution, pi 1 minus x whole thing square by t, then all those things will come out, right? There is 1 minus x here. It will help you in applying the method of substitution. So again, it's a very easy task. The answer will come out to be, at the end, it will be 1 by 2 pi if you do the computation easily. Is it clear, guys? Are you following what I'm trying to explain to you?
Yes, sir.
Okay. Anyone who has any doubt? If you have any doubt, you can tell me. I'll just repeat the idea again. Any doubt, anyone? Okay. I'll take that you don't have any doubts. So maybe we can move to the next problem. And guys, if you have any question, please ask me directly, because I don't have the like luxury to move to the inbox, chat box, and everything at the moment. So maybe if you ask me directly, I can respond to you immediately. That is what I would very much prefer at the moment. So the next problem, it was asked in JAM 2022. It was in mathematical statistics. So the value of this integral. So maybe I'll just write the question. Double integral of x plus y whole thing squared e to the power twice y x plus y dy dx. You want to integrate this over inner integral is y, then x. So y goes from 0 to 2 minus x. X goes from 0 to 2. Now if you look at the function that you want to integrate, x plus y, all these things, it's like a very messy looking function, right? It looks like a mess. So how would you approach this problem? Guys, if you have any idea, you can just communicate. How would you like to approach this problem?
So we can replace x plus y by 2.
Pardon?
We can replace x plus y by t, and then
Yeah.
proceed.
Yeah, very good. We can replace x plus y by one variable, right?
Yes.
Yeah, and yeah, that is the idea actually. So can you tell me why we should be doing that, so that the rest of the students can also get the idea?
Actually, sir, I saw that there is x plus y whole square.
Uh-huh.
So we are getting two terms including x plus y. E raised to 2y by x plus y. So from that I thought to replace it by t.
Yes, yeah. There is these terms, like if you look at this, you're talking about this x plus y, right? This one and this one.
Yes.
Yeah. So these two are very much a clue to you that maybe you should try the method of substitution of variables, right? Because in exam, if I went to the exam hall and if I don't know the method of substitution, maybe I'll start scratching my own head, because this kind of integrals you will need to apply the method of substitution. Okay. So what we will do is, so guys, this is your clue that you should apply the method of substitution when the function is hard, like it's a when the function looks like a mess, it's big. Most likely you should adopt the method of substitution. So here's one clue. The other clue here is, if you look at the limits for y goes from 0 up to 2 minus x, right? Y goes from 0 to 2 minus x. So y, the upper limit is y equal to 2 minus x. So if you bring x to this side, it will be something like x plus y equal to 2. So if you change the variable, then that, like someone said, if you change it into some other variable like u or t, I'll just call it u, then this will precisely give you the limit for the new variable. Are you guys following? I mean, I'm just trying to show you how you have clues in the question, how you can find a clue in the question. Are you guys following?
Yes, sir.
Yeah. Okay. Okay. So taking the clue, I'll just put x plus y, u, and the other variable is just x. X goes from 0 to 2. So we don't have to do anything with x, right? So I'll just replace x by v, because we tend to write in pairs, right? u, v, x, y, like that. So I'll just introduce v, replace x by v. That's what I'm going to do. Now, when you apply the method of substitution, there is something called Jacobian, right? Jacobian. What was the Jacobian? I covered that in the last session. Now, it was something like this. If I'll just digress for 1-2 minutes. If you change variable like this x, if you replace it as by u and v, y, if you replace it by u and v, then the Jacobian j is nothing but the determinant of del x del u, del x del v, del y del u, del y del v. This was the method that I covered last time. Now sometimes it might not be the case that it might not be very easy for you to write x explicitly as a function of u and v, or y as a function of u and v. So sometimes what you may find is, you'll find something like you can write u as a function of x and y, v as a function of x and y. It's like the other way around, not x as a function of u and v or y as a function of u and v, but rather the other way around. U as a function of x and y, v as a function of x and y. In that case, what you do is you find the determinant of the determinant of del u del x, del u del y, del u del y, del v del x, del v del y, and you replace it not by j but rather by 1 by j. That is what we covered in the last session. Is it clear, guys? Okay, so I could write x as a function of u and v and y as a function of u and v, but instead of that, I'll just show you how this method is done. So maybe I'll just keep as it is. So u is x plus y, v is x. So we have u to be x plus y, v equal to x. Then 1 by j is nothing but the determinant of, you find all these things, then it will be the determinant of 1, 1, 1, 0. So that is nothing but minus 1. Right? 1 by j is minus 1. So our j is minus 1. That is our j. And that j will come up when we try to apply the method of substitution. So look at the function now. We have replaced x plus y by u. X plus y by u. So what is this y now? Y, if you replace x plus y by u, then y is equal to u minus x, or x was v, right? So y is nothing but u minus v. So y is our u minus v here. So if you apply the substitution, it will be u squared e to the power twice y is u minus v, by u du dv. So the limits of u, what? And the limits of v. Now to find out the limits, let's look at the limits of the original integral. So the limits were y going from 0 to 2 minus x. So if you put y equal to 0 in this substitution, then you get y to be, okay, maybe I'll just write here. Yeah, if you put y equal to 0 here, then you get u equal to x. And what is x? X nothing but v, right? U equal to v. So that is your starting limit for u. And the upper limit for y was y equal to 2 minus x. So y equal to 2 minus x. So that is nothing but x plus y equal to 2. That is x plus y is u equal to 2. So u goes from v to u equal to 2. So the limits of u are u going from v up to 2. Next, the limits of v. V is nothing but x here, and the limits of x are 0 and 2. So this remains as it is. There is no change. There is no change in the limits of v. So there is how we have changed the phase of the function that we want to integrate, and it is all now very easy. So you have u squared e to the power twice of, I think there's 1 minus v by u, du dv, then u going from v to 2, v going from 0 up to 2, right? So now it's all very easy. The task is very easy now. You can just do some computation. Then the answer will be something like e to the power is 2 to the power 2 times of e squared minus 1, and that is approximately equal to 12.8. Guys, is it clear how we have found the clue and how we tried to solve this?
Yeah.
Would anyone like to ask any question regarding this problem? If anyone has any doubt, any problem, you can ask.
Sir,
Yeah.
why don't we replace dy with u minus v?
Why don't we replace which one?
dy dx into v minus u minus v into dv.
For which part? Like
Where we change the integral
in this integral?
as a next step.
Your voice actually, your voice is like not coming So your voice is breaking actually. So I'm not getting what you're trying to say actually. Can you please repeat what you are trying to say?
Sir, in the next step, we replaced x plus y with u and y with u minus v now.
Yeah. X plus y was u. Yeah.
There, why don't we change y with v minus u in dy and dx?
Acha, you are saying why don't we change y with v minus u?
Yeah,
Right?
u minus in the dy by dx we changed into du into dv now, sir. Why don't we change into u minus v into dv?
du minus v into dv.
Yes.
Du minus, you mean this one, du minus v. Yeah, first thing, like why we use this substitution is that this was the clue that we found in the question itself. Why x plus y, we changed it into u. Because you have something like x plus y occurring repeatedly, right? X plus y, and also in the limits. I showed you why the limit might also give you some clue, right? Y equal to 2 minus x, so x plus y equal to 2. So x plus y happens to come out repeatedly. Do you see that one?
Yes, sir.
Yeah, so there is one clue why we use this x plus y to change it into some new variable u, so that you can, like make use of all the things that we have got so far and then solve the problem. Like if you see this, all this substitution helped us in solving the problem. Are you following?
Yes, sir.
Yeah, so like the substitution basically, like the idea is look at the function first and then find the clue, like which one you would like to replace. Because if we replace arbitrarily in place of x plus y, if we did some kind of replacement like something like say x minus y to be u, or just xy equal to v, without paying attention to the function, then it wouldn't give us much help. It will all depend on the function and also on the limits given to you. Like it will depend on the problem. You just have to look at the problem and go ahead with the best possible substitution that you have at hand. Are you following?
Okay. Okay, sir.
Okay, yeah. So like that is it. So should I move to the next problem, guys?
Yes, sir.
Okay, yeah. So this is the next problem. If for some alpha belonging to so alpha is given to be a positive real number, and alpha is such that if you integrate 2 to the power minus x squared dx from 0 to infinity, it will be alpha times root pi. Then what is the value of alpha? Up to 2 decimal places. That is what we are asked to find. Now, any hunch about how you would like to approach this problem, guys? Please speak out. How should we try this problem? Can you tell me? Guys, please come to the table and just interact with me. There's nothing wrong with giving an idea which might be wrong. That is all okay.
Sir,
Mm-hmm.
uh, does it have anything to do with the gamma function?
Gamma function, the definition was, I think, gamma of x is e to the power minus x minus t alpha t to the power x minus 1 dt. Is it gamma function going from 0 to infinity? In the gamma, I'm not very sure. If there was, I don't remember at the moment, but I think this is the definition of the gamma function, right? Gamma x is 0 from infinity, e to the power minus t to the power x minus 1 dt. If there is any link of this if you can link this up with gamma function, maybe there is, maybe there isn't, but I don't know at the moment. Like, I haven't tried to find out that link, but you can solve this without gamma function too. Like, as for example, if you, I think you're aware of this integral, right? E to the power minus x squared dx, x going from minus infinity to infinity is nothing but root pi. You are aware of this very special integral, right? Minus, okay, this time it's not minus. The other is 0 to infinity. If you try to integrate this function, minus x squared dx, you will get it to be root pi by 2. And these two you should remember by heart because these are very important, these two integrals. So I'm sure that you have come across these two, right?
Yes, sir.
Yeah, so there is nothing special about the e here. You can replace this e by 2 or by any positive quantity. So maybe you can always find, for any alpha, for any k positive, you can always find k to the power minus x squared dx, x going from minus infinity to infinity or from 0 to infinity. You can always find this integral for any k positive. The method is very much the same as how you find this or this. Right? If you recall, suppose you want to find this, right? 2 to the power minus x squared dx 0 to infinity. I'll just replace. So 2 to the power minus x squared dx, x going from 0 to infinity. You want to find this integral, so I'll call it I. I'll define it by I. And x is a dummy variable, so I can replace x by y as well. So 0 to infinity to the power minus y squared dy. So if you multiply this and this, what you get is I squared. I squared is nothing but x going from 0 to infinity, y going from 0 to infinity, 2 to the power minus x squared plus y squared dx dy. Right? If you multiply this, you get I squared is equal to 2 to the power minus x squared plus y squared dx dy, x and y going from 0 to infinity each. So all these things come out, so you can easily do this double integral now, very easily, because you can apply, you can change it into polar coordinates, x equal to this, y equal to r sine theta, and then the integral becomes I squared is equal to, so look at the limits, x going from 0 to infinity, y going from 0 to infinity, right? So it is nothing but the first quadrant. You are trying to integrate it over the first quadrant. So the limits in terms of r, it would be, so this integral, if you change it into polar coordinates, it will be I squared is equal to r going from 0 to infinity, right? Theta going from 0 to pi by 2. And 2 to the power, you can replace it by r squared very easily, minus r squared. And dx dy is always replaced by r dr d theta. So there is r squared, there is r dr. All these things are very easy now. So you will get something like I squared is, if you compute, it will be pi by 4 log 2. Therefore, I is 1 by 2 square root of log 2 root pi. So this is our alpha now, right? Alpha is 1 by 2 square root of log 2. This one, and that is precisely, or approximately, it is 0.6. Are you guys following what I'm trying to?
Yes,
So
sir.
yeah. So when you get such an integral, the idea is to use the method that we use to find this one. How we find the integral of e to the power minus x squared over 0 to infinity or over minus infinity to infinity. There is nothing special about this e. You can replace it always by any positive k. And for our example, we have k equal to 2, and that is how we have done it. Okay.
Hello, sir.
Yeah.
Would you explain me more about the graph, actually, the geometrical approach?
The limits.
Right.
Okay. Yeah. So the question was this, right? I was this one. We defined I to be this integral from x going from 0 to infinity to the power minus x squared dx. This was our I. X is so we don't have any direct method of doing this integral. So we are going to take the help of the double integral by finding by replacing this x, because x is a dummy variable. I can replace it by y, correct?
Right.
Yeah. So when I replace it by y, I get 2 to the power minus y squared dy, y going from 0 to infinity. Now if you multiply these two, if you multiply these two, I, you get I squared, right? And it becomes a double integral, 0 to infinity, 0 to infinity, 2 to the power minus x squared plus y squared. Precisely this one. Are you following?
Yes, yes.
Yeah. So this becomes a very beautiful double integral that we can find, because we have covered these things in the last session. X squared plus y squared. The limits of x are 0 to infinity, and the limits of y are 0 to infinity. So 0 to infinity in the positive direction, 0 to infinity in the positive direction. So x goes from 0 to infinity in this direction, right? Y goes from 0 to infinity in this direction. So that is precisely the whole first quadrant, right?
Uh,
Do you have any doubt about this?
Very abstract out, actually. X is towards infinite, and also
Yeah.
y is it infinite to, like, y axis mainly. So
Pardon?
I didn't get to visualize what is the actually.
Yeah. Do you visualize the area over which we are trying to integrate? X going from 0 to infinity, y also going from 0 to infinity. So if you look at the xy plane, x goes from 0 to infinity, so like this, y also goes from 0 to infinity. So this area is precisely the whole first quadrant, right?
Yes.
The bound of x is x equal to 0 means this y axis, and up to infinity. So there is no limit on the value of x. and the limits of y are 0 and infinity. Y equal to 0 is precisely this x-axis, and there is no limit on the value of y. So precisely you get this first quadrant, right? Any doubt?
No.
Okay. So if you replace, if you make a change of variable with this, x equal to r cos theta, y equal to r sin theta, then in polar coordinates, the r will go from 0 up to infinity, right? R can go from 0 up to infinity, the radius vector, right? In the first quadrant, the value of r that we have, it goes from 0 up to infinity. Clear?
0 up to infinity. Right. Sir.
Because there was no bound on the value of x and y. The only lower bounds of x and y were x equal to 0 and y equal to 0, right? There were no upper bounds. So if you take r, it will go from 0 up to infinity. What is r? R is nothing but in the polar coordinates, if there is any point, this is the initial line. This is any point represented by r comma theta. This distance is r, is the theta, right? So this r, there is no limit on the value of r that it can assume, because there were no upper bounds on the values of x and y. So r can go from 0 up to infinity, right? Okay. And what are the bounds of the values of theta? It was the first quadrant, right? In the first quadrant, theta can go from theta equal to 0 up to this one, theta equal to pi by 2. Clear?
Yes,
So
sir.
the limit, yeah. So the limits of theta are theta going from 0 up to pi by 2, and that is what we have done precisely. And the rest is very easy. Okay.
Okay, sir.
Any more doubts?
No.
Okay. Then we can move to the next problem, which is asked in JAM 2022 Mathematics. So f is a function defined by fx to be blah 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 when x lies between 0 and pi by 2, and when x lies between pi by 2 and pi, x is blah blah blah. You are asked to find the integral of fx over 0 to pi. So I'll just write the function fx again. Fx is nothing but x minus pi e to the power sin x. X minus pi e to the power sin x when x lies between 0 and pi by 2. X lies between 0 and pi by 2. And it is precisely x e to the power sin x plus 4 pi when x lies between pi by 2 and pi. So you are asked to find what is the integration of fx over the integral over the limit 0 and pi. So what is this integral? Any idea, guys? These are your question. Fx is this given like this when x lies between this, all these things. And what is the integral of fx over 0 and pi? Any idea, guys? Any hunch? Any starting idea how we should proceed?
So we can, can we replace x by sine inverse of t?
We can what?
We can replace x by sine inverse of t.
X by sine inverse of t.
Yes.
Okay. Let's see how it works. Sine inverse of t, and then sine inverse of t. So the idea why you are telling me this is so that sin x becomes t, right?
Yes.
Okay. So if we do this, then sin x becomes t. And if sin x becomes t, then this part becomes, so this x becomes sine inverse of t minus pi e over t. It becomes something like this, right?
Yes.
Okay. And how do we proceed after this? Because you'll have to do this. So there is a product of e over t with sine inverse t. So when you want to integrate, you'll have to at least apply the integration by parts. I think, yeah, there is, I think, that one. Right? 0 to at least pi by 2, it is 4 days. We have to find this, right?
Yes.
Correct? Yeah, so is that what you were trying to say? Like by replacing this, we can go ahead with this one. Was this your idea?
Yes.
Okay. Yeah. And have you tried this problem with this, like with this idea? Because I haven't tried it yet. But have you tried?
Actually, uh,
We haven't tried.
Yeah. Did you get the answer?
This.
Okay.
I didn't try it.
Okay. You didn't try, but this was your hunch, right? Okay.
Yes.
some difficulties will arise proceeding this way. Actually, I don't know. Maybe I will be wrong. E to the power t upon sine inverse into sine inverse x. So sine inverse x Taylor's expansion, and it will get bigger. Like is it integrable? Like on limited, like real field and all.
The thing is, like, see, this is a product of two functions, right? E power t, it's a smooth function, and the derivatives never vanish. So even if you apply something like, so what do you do in, you know, the integration by parts is u v dx. So u integral of v minus integration of du dv, du dx, I think, into integral of v again dx, right? So this thing, if you put u equal to e power t, then this will never vanish, right? This will go on, this will keep on being e power t, e power t, e power t forever, right? Because e power t is, the derivatives don't have any effect on e power t. If you change it and if you put u to be sine inverse of t, then du dt, sine inverse of, okay, x, I'll just replace it by x. Then du dx will be, is it minus 1 by square root of 1 minus x squared, right? So that becomes complex again. Are you following?
Yes.
So yeah, your idea that sin x by t. So if you try to replace it, yeah, it becomes, like this thing becomes simpler when you look at it. But when we try to integrate this, it becomes a little bit, complex. So the better way to be, going ahead with is to look at some other way. Because if you look at the question, maybe I'll just, so yeah, if you, if you look at the question, see, there's a, you will find some pattern. Like the pattern is x minus pi this one and this one. There is some kind of, like there are some similarities. Do you see the similarities? There's a x minus pi e power sin x and x e power sin x, right? So we will be exploiting this similarity to solve this problem. Before that, maybe I'll just show you what this is. Suppose you have a sine graph from 0 to twice pi. This is y equal to sin x, 0 to twice pi. What do you get? If you integrate sin x over 0 to twice pi, the answer is 0, right? This pi with pi. The answer is 0, right? If you integrate sin x over 0 and twice pi, the answer is 0. Precisely because the positive area that you have is cancelled exactly by this negative area. And so the answer is 0. Clear?
Yes.
Yeah. So if you look at this, why was this happening? That was because, look at this. The sine graph have this property. Like from pi, if you look at this direction and look at this direction, sine of pi plus t for any like suppose t is between 0 and pi, okay? So sine of pi plus t, this one, suppose consider this length to be t. Sine of pi plus t, this value that you have is exactly the negative of, if it, this one, this, if this is t, the negative of this one. So whatever you get here, this will be exactly the negative of this. Are you following? For any
Yes.
t between 0 and pi. So if you take t, this, if I call it t1, if this was t2, whatever you get here will be exactly the opposite of what you get here. The negative of this, it is t2, this t2. So sine pi plus t2 will be equal to the negative of whatever you have. Are you following?
Yes.
Yeah, so we will apply a similar idea in this problem as well. So they are asking us to integrate from 0 to pi, right? So pi by 2, I'll demarcate it in half. For any t between 0 and pi by 2, what is the value of f pi by 2 plus t? So it is definitely more than pi by 2, right? So it will be pi by, so you'll be using this one. So it will be pi by 2 plus t, e to the power sine pi by 2 plus t plus 4 by pi, what we have here. Okay, so that is nothing but pi by 2 plus t e to the power cos t plus 4 by pi. This one. What about f to the power f of f pi by 2 minus t? This is pi by 2 minus t, so that will be less than pi by 2. So we'll be using this one. So it will be x minus pi of this. So x is this one. So it will be pi by 2 minus t minus pi e over sine of pi by 2 minus t. So it will be minus pi by 2 minus t. So there is a minus pi by 2 plus t e over cos t. So do you see any link of here, this one and this one? Do you see any thing like this phenomenon that I have described here? Can
The
you see?
negative of first function.
Yeah. So that means what? what you get is, if you integrate this function fx dx from 0 to pi, right? So what these two, this one and this, what this means is that, let me make a small diagram. So 0 and pi. So what we have found by these two is that whatever value that we get here for any t between 0 and pi by 2, whatever value that we get here, maybe this one, exactly the negative of that we'll get here. Whatever we get here at this point, something like this, exactly the negative of that we'll get here, something like this. So it will be something like, if it is, the graph is something like this, then it will be something like this for this, that one. So the area under this, the positive area will be exactly cancelled by this negative area. Are you guys following?
Yes.
Is pi by 2. So if you integrate this function over 0 to pi, then this one and this one will cancel each other. So the only thing that remains effectively is this 4 by pi. And 4 by pi comes under this jurisdiction, right? X going from pi by 2 and pi. So it is effectively pi by 2 to pi, 4 by pi dx, and this is 4 by pi into pi by 2. It will be just 2. The answer is 2. Are you following, guys?
Sir, one doubt. Why we take 4 by pi in the interval pi by 2 to pi?
Why we take which one?
4 by pi in the interval pi by 2 to pi.
Acha, 4 by pi. 4 by pi comes from this definition of the function. Look at this. There was one extra 4 by pi in the definition of fx, right? This was how we have fx. There is one 4 by pi here, extra.
Okay, sir.
And the limits of 4 by pi are pi by 2 to pi. This the 4 by pi value comes up when x lies between pi by 2 and pi. So the limits also becomes pi by 2 to pi and 4 by pi.
Okay, sir.
Any doubts, anyone else with this problem?
No.
Okay, so maybe we can move to the next problem. This was asked in NBHM 2020. Evaluate minus infinity to infinity 1 plus 2 to the power 2x4. Well, let's write the question again. Minus infinity, say infinity tak, 1 plus 2 x power 4 e to the power minus x squared dx equal to what? How would you go ahead with this problem?
Maybe we can evaluate the integral to two functions.
Integration to functions.
Yes.
Which kind of functions?
That means 1 plus 2x raised to 4 and e raised to minus x square. Can we evaluate separately?
You mean something like I'll evaluate this like finding the integral of this separately and this one separately. Do you mean that one?
Yes.
So that I think would you mean integration by parts, like you consider this to be u and v, something like that?
Yeah. Can we try like this?
The thing is, if you do that, yeah, let's check out whether that is going to work or not. I haven't tried the integration by parts for this, but let's try it. So if I put this, if I consider this to be u, this to be v, then the thing is, yeah, I think you can do it. Yeah, you should be able to do it. Yeah. Because integration u v dx is u integration of v, right? If you substitute this by v, then what is v? V is e to the power minus x squared. So integration, this v is e to the power minus x squared dx between minus infinity and infinity. That is the value root pi. So this comes out to be root pi minus integration of du dx, right? So there is a polynomial of degree 4. So this will become a polynomial of degree 3. And inside it will be replaced by root pi. And you have something like this, right?
Yes.
Yeah. So maybe, okay. Pi and okay, let's try it the way you have suggested. So it will be minus infinity to infinity, whatever it is. U integration of v minus u is 1 plus 2 x power 4 minus v. There is one problem actually. The problem is that, see, I overlooked at that problem. See, the problem is when you apply integration by parts, when you actually have limits, the advantage of these limits for this function is that you readily know the value of this integral, this root over pi. But if when you apply it to something like this, it should be u times the integral of v. So how this works is, first you integrate the function e power x squared without looking at the limits, multiplied by u, 1 plus whatever this function comes out to be, multiplied by u to this one, and then substitute the values this one, right? That is how it works. But
Oh, yes.
yeah, but there is no way of finding this integral, right? We don't have any way of knowing what this function is without knowing the limits. Clear?
Okay, sir.
Yeah, so that is like a hard, there's something hard that I have not come across the solution of this without the limits. So if there is any solution, then it should work. Maybe we can deal with the limits, but I haven't come across anything where you integrate this without knowing the limits. Clear?
Yes, sir.
So yeah, it looks like we can apply direct integration by parts, but sometimes there is another way to solve such problems. So maybe I'll show you how that is done. We will be using this one though, whatever this integral that we have, we will be using this one. We will be needing this one. So if you look at the problem, then you can break it. Okay, that's right. 1 plus 2 x power 4 e power minus x squared dx minus infinity to infinity. You can break it up into two parts. This one into this, e power minus x squared dx minus infinity to infinity, plus 2x power 4 e power minus x squared dx minus infinity to infinity. That is our root pi from this one. So the only thing we have to work is this integral, plus infinity to infinity 2x over 4 e power minus x squared dx. This we have to work. So 2x power 4 e power minus x squared dx minus infinity to infinity. Wait.
Sir,
Mm-hmm.
I
used a substitution x to the power 2 equals to z, and then I used gamma function.
Yes, 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 precisely. That is how we do this problem. Exactly. Okay. So there's one 2 here. Okay, minus infinity to infinity, right? So I can bring one extra 2, 0 to infinity. There's 1, 2, x square 4 e power minus x square dx. So it will be 4 times of 0 to infinity. So just like C suggested, that is exactly the method that I had in mind. So you can substitute x squared by z. Then 2x dx will be dz, and all those things, the limits all will be taken care of. So this one will become, I think it will be 2 times of 0 to infinity z to the power 3 by 2 e power minus z dz. And if you recall, gamma of x is e power minus t, t power x minus 1 dt. Is it correct what I'm writing? Like if it's wrong, please point out. Is it correct, the definition of gamma x?
Yes, I think it's correct.
Yes, sir, it's correct.
Okay, so if it is like this, then I can go ahead with 0 to infinity z. I'll replace 3 by 2 by 5 by 2 minus 1, right? E power minus z dz. So that is precisely 2 times of gamma 5 by 2, right? Clear?
So how does it become z raised to 3 by 2?
Acha, how does it become?
Z raised to 3 by 2.
Okay, so that one comes from this substitution and everything that we have to take care of, right? So I have replaced x squared by z. Okay, I have replaced x squared by z, so that 2x dx is dz, right? So if I replace x squared by z here, then 2x dx will be dz. So that is 2 times of x to the power 3 e power minus x square 2x dx. So there is some 0 to infinity. There is some adjusting that you have to do. So 2x will become dz. This is z. X. What is x now? X is square root of z, right? From this you get x to be square root of z. Then x to the power 3 will be, this x to the power 3 will become x power 3 will become z to the power half to the power 3, 3 by 2. Are you following?
Yes.
So z to the power 3 by 2 e power minus z dz with infinity. That is what we have here. Clear?
Yes.
Okay. So we have 2 to the power 2 gamma 5 by 2. Right? Is it correct, guys? Guys? Guys, please speak out.
Yes.
Okay, sir.
Okay, so we have gamma 5 by 2. Now, the next step is there's, yeah, what, tell me what you would do next. You have this one. What is, how do you find gamma 5 by 2? How would you go to the next step?
So we can use gamma of n plus 1 is equal to n factorial.
Yeah, but that is, the factor wouldn't work here because this is not an natural number, right? This is not, yeah, that one works when n is,
So we can write it as 3 by 2 plus 1.
yeah, so the property is x plus 1, no, 3 by 2 plus 1, right? But 3 by 2 factorial, it doesn't make sense, right? If you use this factorial, it doesn't make sense. 3/2 factorial doesn't make sense, right?
So the answer will be that is 5/2 into 3/2 into gamma 1 half.
Yes, yes. So the property is gamma x plus 1 equal to x gamma x, right? Gamma x plus 1 is exactly equal to x gamma x, I think. Do you remember this property of gamma function?
Yes, sir.
Yeah, so apply that one. 2, you can replace it by 1 plus 3/2. So it will be 2, 3/2, gamma 3/2. Apply this the same property here again, and you'll get 2 into 3/2 into 1/2 into gamma half. And gamma half is exactly equal to root pi, right? 2 to cancel, so it is 3/2. So it will be 3/2 root pi. Yeah, it's just root pi. There's nothing below. So it is root pi. So it is 3 root pi by 2. So this is the second part of the integral we have here. So this root pi, the second part is 3 root pi by 2. If you add it, this one and this one, if you add this root pi and 3 root pi by 2, you'll get 5 root pi by 2. So answer is root pi plus 3 root pi by 2, 5 root pi by 2. Clear, guys?
Yes, sir.
Okay, let's move to the next problem. The value of this integral, rounded off to 2 decimal places, is what? Double integral mod x plus y dx dy. The limits of x are -1 and 1. So the limits of x are x going from -1 up to x to 1. Y also goes from -1 to 1. So y also goes from -1 to 1. So this gives you exactly this square. You have to integrate whatever function there is over this square that we have. Can you tell me, guys, how we should proceed with this problem? I'll just write the function here. Mod x plus y dx dy. X going from -1 to 1. Y also goes from -1 to 1. How would you go ahead with this problem? Any idea? Anyone?
So we can like break the integrals
Mm-hmm.
in the form. First we take -1 to 1.
Mm-hmm.
Then break the integrals next term from -1 to 0 and 0 to 1. And that way we can
Yeah, like -1 to 0, 0 to 1.
yes.
Can you tell me why, like the reason behind that, why we should be breaking that way?
Actually, I saw absolute value, so it came to my mind.
Yes. So the basic idea is like to take care of this absolute value, right? Because
Yes.
yeah, you are asked to integrate a certain function, and the function has absolute value. So we can't integrate it directly unless we take care of the limits, correct? So your idea was you're talking about -1 to what? It was 0 or something like what were you telling me?
-1 to 0.
And
then 0 to 1.
0 to 1. So that this whole thing becomes x plus y, correct? Because the x is positive, y is positive, so x plus y is positive, so mod x plus y will be x plus y. This is what you mean?
Yes.
Wait. -1 to 0. If we take the limits of x will be -1 to 0, then x is negative. Y, the limits will be positive. So x plus y could be positive or negative. We can't exactly precisely say that x plus y is this or that.
So we can take x2 away from -1 to -y. Then
Pardon?
we can take the limit of x from -1 to y, -y.
-1 to -y.
Yeah. So at -y it would be 0. And after that we can split it again.
Okay. Maybe you should. Can you repeat? The limits of x are minus. Okay. Let me write it down. Yeah.
-1 to -y.
-1 to -y.
Yeah.
Okay. -1 to -y. -1 to -y. And the limits of y?
It's from -1 to 1.
-1 to 1.
Yeah.
Okay. So the limits of x are -1 to -y. So x goes from. Let me look at the figure. X goes from -1 कहाँ तक -y. X equal to -y would be like this. So x goes from this one to this one, right?
Yes.
And y goes from -1 यहाँ से यहाँ तक. Y equal to 1. Y goes from -1 to 1. So you're first integrating it exactly over this region, right? Exactly. That is correct. Yes, that is correct. Can you tell me why you are taking these limits? That is correct. Your idea is correct. Can you tell me?
So when we deal with absolute value, we usually break the limits in that sense so that we get 0 in the upper limit for the first one. So here we have x plus y term. So I'm taking -y because x plus y would be 0 at x is equal to -y.
Okay. So yeah, you mean along this line, right?
Yes.
Okay. So one part of the integral is this. So over this region, can you tell me what the values of x plus y would be? So you are integrating the function x plus y over this region, right? Over this region that you have described. Your idea is correct, yes. But can you tell me why?
Minus of x plus y.
Exactly. So guys, she has told me the right idea. I'll explain to you why this is the case. See, the function that we are looking at is mod x plus y, right? You have to take care of this mod. Before you integrate it, you have to take care of this mod, right? So just look at the function, this one. X plus y equal to 0. What does this represent? It represents in the xy plane, x equal to y, x plus y equal to 0. It represents this line, right? This line is x plus y equal to 0. Correct? Guys?
Yes, sir.
Okay. So, and what about x plus y equal to k, where k is positive? When is x plus y positive? X plus y equal to 0 is this. And what is x plus y equal to k, where k is positive? It should be any line parallel to this one, right?
Yes, sir.
And that will happen if you move in this direction. Correct? If you have a line something like this, parallel to this, then the equation of that line would be something like x plus y equal to k, where k is positive, right?
Yes.
And if you move this line in this direction, then and keep it parallel, then the equation would be x plus y equal to, instead of k, I'll take maybe m. Let me rub it. So the equation of this line would be x plus y equal to m, where m is negative now, right? Yeah? Yeah, so if you look at this you have to integrate the function x plus y over this square, right? You have to break up this square in such a way that you can take care of this mod function. So I started with this one, right? So just like how she told, that is exactly the correct idea. X plus y equal to 0 is this line. So our x plus y equal to 0 would be this line, right? So I divide it into two regions. See, the first region is this one. This is our first region, and the second region is this one. I'll call this region A2 or maybe A1, just like how she mentioned, and I'll call this A2. And if, just like what I've told you just now, if you move it in this direction, the x plus y will be positive. If you go in this direction, the x plus y is negative. So in this region A2, what is x plus y? Will it be positive or negative in the region A2?
So it will be positive.
Exactly. And in A1, what will it be?
So it will be negative.
Yes. It will be negative. X plus y will be negative in A1, x plus y. So, yeah, that is how we take care of this integral. Double integral of minus 1 to 1, minus 1 to 1, mod x plus y dx dy, mod x plus y dx dy over A1 first, and then over A2. X plus y dx dy over A2. And in A1, x plus y was negative, right? In A1, x plus y was negative, right? So I'll just replace x plus y by negative of x plus y. Okay, let's compute them separately. So double integral of x plus y dx dy over A1. This is negative in A1, so I'll just replace it by negative of x plus y. See, we have taken care of the mod now in A1. And you can easily integrate this because we have been doing this like 1,000 times now, right? You can easily integrate it over this triangle. It's very easy now. Okay? Guys, are you following?
Yes, sir.
Yeah, if you integrate it, the answer will be 4. Okay, I'll just write the answer here. 4 by 3. Okay? And look at the function. There is some, I'll make use of the symmetry of the function. Mod x plus y is here, the function, and the triangle is this. This gives you 4 by 3. So the same result will come out for this one by symmetry. Okay, so for over x A2, also it will be over A2, it will be 4 by 3. Therefore, the answer is over the region, whatever that was, 4 by 3 plus 4 by 3, it will be 8 by 3. It will be approximately 2.66. Clear, guys? The symmetry, yeah, the symmetry is like consider it's similar to the symmetry of the mod function in one variable over the interval minus a to a. If you integrate this mod x dx from minus a to a, it will be twice of 0 to a, right? So that is the kind of symmetry I have used. Something like this. But you should be careful when you use symmetry. Okay. Any doubt, anyone? Any question? Guys?
No, sir.
Okay, so the idea here is that break the area into two parts, or into how many parts that you want to or you need to take care of the mod for this question. So we will be doing something similar with the next problem too. This was asked in NBHM 2018. Double integral over the area A. A is nothing but the unit square, 0, 1 cross 0, 1, cos pi max of x and y, dx dy. How do you take care of this? Cos pi max of x and y dx dy over minus 0 to 1, 0 to 1. Yeah, can you tell me, guys? Apply something similar. The idea should be something similar to this. Here it was mod x plus y. In this problem, it will be max of x and y. How would you take care of this max of x and y? Tell me, guys. Break up this area into two parts, this whole unit square that we have. Try to break it up into, okay, I'll tell you the number of parts, 2 parts. Break it up into 2 parts such that you can take care of the max function. The max function that is like creating trouble for us at the moment. How would you take care of that? By breaking the area into 2 parts. See, if I break it up, say this line has the equation x equal to y or y equal to x, whatever it is, right? Correct? And what about this region now? This small triangular region. In this region, which one is true? Is it x greater than y or y greater than x in this triangular region? Which one is true?
X greater than y.
Yeah, I'll call this region to be A1, and in the A1, x is greater than y. What about in this upper triangular region? Is it the other one, right? It will be x less than y or y greater than x. I'll call it A2. Correct? So if I break it up into 2 parts, cos of whatever it is over A1, this is the A1 that we have, this triangle, the lower triangular region, plus cos of whatever the function is over A2. Let me just write the cos, otherwise it will be confusing. Cos pi max of x and y. Cos, yeah. Cos of pi max of x and y dx dy over a1 plus the same function cos of pi max of x and y dx dy over a2. And in a1, in this region a1, in this region a1, x is greater than y, so max of x and y will be x, right?
Yes, sir.
So in this a1, cos of pi max of x will be x dx dy over a1, the limits you take care of it. And in the other region, कहाँ से? Yeah, A2. A2, x is less than y, so the max of x and y will be y here, right?
Yes.
So cos of pi y dx dy. So over A2. The limits you take care of it. So it's very easy now to. So that is how we took care of the max function by breaking it up into two parts, such that you can take care of this max function. That is the idea. Clear?
Yes, sir.
Now you can easily do this problem, and the answer, I'll just write it down. It will be minus 4 by pi squared. That is your answer. So let's go to the next problem. The volume of this region R equal to this, blah, blah, blah is what? So we have done this problem like 1,000, not 1,000 times, but at least 2 or 3 times in the last session, I think. So the volume V is nothing but triple integral of, okay, I told you something in the last one, right? Dx, dy, dz. And the region R over which it should cover. The R given to us is this, x, y, z, such that x squared plus y squared less than or equal to 4. Z lies between 0 and 4 minus y. Yeah, so you have to cover the idea, not the idea, but the formula rather is volume V. Volume V is the triple integral of 1. We don't have to write the 1, but that is it. Dx, dy, dz, and you have to cover it over the entire region R. Now, which one should be our innermost integral? Should be a function of x, should be a function of y, should be a function of z. We can permute them depending on our question. So by looking at the region R, can you tell me which one should be our innermost integral? Should it be x, should it be y, or should it be z?
Z.
Yes. Z. Can you tell me why it should be z?
Because it has its upper limit as 4 minus y.
Yeah, because the limits of z are prescribed to us, right? If you look at this. So it should be z first, and dx dy, z going from 0 to 4 minus y, like what it is given, and the remaining will be some area over in the xy plane. I'll call it d. And what is d? D is nothing but this disk, x squared plus y squared less than or equal to 4. I'm calling it d. So that is z. If you do this innermost integral, you'll get 4 minus y dx dy over d. d क्या है? d is just xy such that x squared plus y squared less than or equal to 4. This I have taken out from the question. You can do this very easily now. We have done this kind of problems. Because it's a disk, I can replace, use polar coordinates, r cos theta, y equal to r sin theta, and all these things can be taken care of. You can do it very easily. The answer is 16 pi. Clear, guys?
Yes.
Okay. We can try the next problem. It was asked in JAM Mathematical Statistics. So let A be blah blah blah. Alpha be the value of this integral. What is this triple integral? So A is x, y, z such that x greater than or equal to 0, less than or equal to y, less than or equal to z, less than or equal to 1. That is our A. Look at this series of inequalities. We are going to need this one. And alpha is given to be the triple integral x, y, z, dx, dy, dz over A. Now, what do you propose? Like, there are 3 variables. So which one should be our innermost variable? Should be x, should it be y, should it be z? By looking at this series of inequalities, can you guys tell me?
Z.
Z.
No, sir, X.
Yeah. If you do Z, there is a problem, right? If you put the Z first, because the upper limit, yeah, we can put 1. But which one do you put? Should you put Y? Should you put X? Should you put 0? There is a problem with starting with Z, right?
Yes.
So rather we should start with X. So because X lies in the smallest section. So the limits of X are 0 and Y. X goes between 0 and Y. If you look at this, X goes between 0 and Y. So it will be X, Y, Z, dx. X goes from 0 to Y. The second, which one should be our second variable? X, we have taken care of it. Which one should be our second? Should it be Y? Should be Z? The second variable. The second, yeah, the variable, the limit of the variable of integration.
Y.
Yeah, it should be Y, correct? It will be Y because we have taken care of this Z. Next will be Y. What are the limits of Y? Which one can we put? Can you tell me the limits of Y? Because there are now two things. Y is greater than equal to X, greater than equal to 0. So you can put Y equal to X. Y lies between X and Z, or you can put Y lies between 0 and Z. Which one would you choose? There are two possibilities. This is our Y. Y lies between X and Z. That is our one of the possibility. The other possibility is Y lies between 0 and Z. Which one would you use?
0 and Z.
Can you tell me the reason why it should be 0 and Z?
Because the inner integral we are already taking X.
Yes, because if we put X here, then the problem is that after we have taken care of X, this X will reappear again, right?
Yes.
That is the reason why, and yeah, that is precisely the reason why we should use the
0 to
0 to Z. Yeah, Y goes from 0 to Z. So the final one is Z. What are the limits of Z?
X to Y to 1.
Y to 1. If you put Z equal to Y to 1, do you see any problem?
0 to 1.
Yes.
Yes, sir. 0. It will be 0 to 1.
Exactly. Yeah, it should be 0. The problem with Y is that if you put Z equal to Y here, yeah,
Y will appear X.
yeah, Y will reappear, right? So we should put Z going from 0 to 1. Z goes from 0 to 1. Here is Z. So Z 0 से 1 तक to 1. Now you can do it very easily. All these things are very easy, and the answer is, I think, 1 by 48. So 1 by 48. So this alpha is 1 by 48. And they have asked us to compute 384 times of alpha. The 384 times of alpha is equal to what? That is our question. That you can easily find to be 8. That is your answer. So the idea is how, if you're given something like this, that is how you take care of the limits. That is the main idea in this step is the main idea, by looking at this series of inequalities. Clear, guys?
Yes.
Okay, maybe let's move to the next problem. As is given by this, okay, that is something similar, right? Like to the last problem. Then the value of this integral is what? So I'll just write down the S again. S is xy such that 2y4. 2 less than x less than equal to y less than equal to 4. And what is the value of this? 1 by 4 minus x dx dy over s. So they are starting with x first and y. How would you approach this problem, guys? So the area over here which you want to integrate is this S. X lies between x 2 and y. So this is x equal to 2. This is x equal to 2. This is x equal to y. X lies between 2 and y. And y lies between 2 and 4. Y lies between 2 and 4. So this is y equal to 2. This is y equal to 4. So you have to integrate it over this region. This triangle. Can you tell me now how we can do this?
So we can start with the inner integral as 2 to y.
X going from 2 to y. Okay, the limits are x moving 2 to y. And y going from 2 to 4, right?
Yeah.
Yes.
Yeah. Then what would you do as the next step? Would you go on integrating directly, or would you like to do something else about it so that
Substitute it. 4 minus x equals to z.
yeah, you can do that, and there will be a respective change of limits. But there's another way to make things easier.
So putting x equals to cos square theta.
Cos square theta. Would it work if you put x to cos theta, cos square theta?
We can change it into dy dx.
There is some, we have done this, like think about something that we have done, something we have done about it. Like, see, there's a hint I'm telling you. You are integrating first with respect to x and then with respect to y. So can we do something about it so that maybe the thing becomes very easy?
So we can interchange the limit.
Exactly. We can interchange the, like, change of order of integration, right?
Yes.
Yeah. If you change the order of integration, this color of the ink, is it clear, visible to you guys? This color, or should I change the color? Is it visible to you guys, the color of this ink?
Yes, sir, visible.
Visible. Okay. So if you change the order of integration, then in this case you were doing it with respect to y, x first, and then with respect to y, right? So let's go the other way around. So this line was x equal to y. So y starts from x and y goes on till 4. So the limits of y are x and 4. So the limits are the limits of y are x and 4. Y going from x to 4, 1 by 4 minus x, dy, dx dy, right? So I'm doing the reverse way, dy dx. The limits of x would be now from 2. This is x equal to 2, right? 2 to till where? Can you tell me?
4.
Yes. The limits of x are 2 and 4. 2, 4. So I can just bring out this function because it's a function of x and you are integrating with respect to y. So I can just bring it out. It will be 1 by 4 minus x into y. Y limits are 4 and x. So it will be 4 minus x. 4 minus x dx. This cancel each other. So you have, see, it becomes very easy now. Dx 2 to 4. So the answer is very easily, it's 2. Clear?
Yes, sir.
Yes.
Yeah, so that's how we have done this problem. Maybe we can move to this next problem. NBH 114, as is this region defined to be, it's a series of n tuples in Euclidean space of n dimension such that x1 lies, look, yeah, the main thing here is look at how the region is defined. That is the main aim here, such that x lies between 0 and x2 less than equal to x3. Like that, it goes on up to xn less than equal to 1. What is the volume of S? So volume of S. Any idea, guys? How do we write the volume now? This is an n-dimensional Euclidean space. So far we have done in 3-dimensional space, right? Now it's n-dimensional. So how do we write the volume of S?
So I can take the integral n times on the space S, and dx1, dx2, dx3 up to dx.
Yes. And what is the function that we should be integrating?
1.
Yeah, 1. I would rather not write that 1, and I'll just write dx1, dx2 to dxn. So just like
y1. y1.
Y, it's not y1, it's x1, x2 up to xn. I mean,
No, sir. What? Why we took functions 1?
Acha, why is this one, right? That is because we like the volume. When you write find the volume of any region in 3 dimension, it was dx, dy, dz. That's 1, right? So
Okay, sir.
yeah, that is what we have generalized in 2n dimensions. And we usually don't write this one, and we just keep it like this. So now tell me, what are the limits of these n variables, x1 up to xn? So first, should we start with which variable would you put as the innermost integral? Should it be x1?
x1. Sir, x1.
Exactly. Limits would be?
Sir, 0 to x2.
Okay. The second would be which one?
Sir, it will be x2, 0 to x3.
Okay, let me just write it. The second integral would be x2. It would be 0 to x3, correct? So like that, okay, tell me the third integral as well. Tell me what the third integral would be.
It will be x3 and the limit x equals to 0 to x4.
Yes, correct. So the third will be x3, 0 to x4. It will go on like this, right? So what will be the last one? The last
Sir,
one?
0 to 0 to 1.
Okay, which variable would it be?
Xn equal to 0 to 1.
xn.
0 to 1. Yeah, that is our volume. Now you can do this very easily, right? You can start off from this, like you can start integrating one by one. You'll find a pattern. Okay, I'll just make it quick. I'll just do the first one maybe. So xn going from 0 to 1, dot, x2, 0 to x3, I think. And x1, if you take care, it will be x2. x1, dx1, x2. So it will be x2, dx2, dxn. So it will be x2 square by 2, so it will be 1 by 2. I'll bring out that 1 by 2. Or rather, I'll just write it for now. 0 to 1. X. There is one x3 also, okay? x3 equal to whatever it is. x3 equal to 0 to x4. Yeah, x2 square by 2. It will be x3 square. Yeah, x3 square by 2 dx3 dxn. I'll pull out this 1 by 2. So 1 by 2 into xn going from 0 to 1. Integration x3 going from 0 to x4, x3 square dx3 dxn. So there will be 1 by 2 into xn going from 0 to 1. x3 square, if you integrate, will be x3 cube by z3, x3 cube. So x4 cube by 3 dx4 to dxn. dx4 will go from 0 to x power x5. So 1 by 3 I can pull it out. 1 by 2 into 1 by 3. So it will go on like this, and finally it will be 1 by n minus 1 integration of xn to the power n minus 1 dxn, I think, xn going from 0 to 1. That is how the answer will come out. Okay? Are you looking at the pattern, guys? How 1 by 2, 1 by 3 comes out? 1 by n? Are you following?
Yes.
Yeah. So
Yes,
this.
sir.
So ultimately it will be 1 by 2 into 1 by 3, 1 by n minus 1 into 1 by n. So that is precisely 1 by n factorial. So that is your answer. Okay? There is a volume of this solid or whatever the region is in n dimensions. Okay, we don't have much time. I still have maybe, I think, okay, this is the last two problems. So let's just cover these two problems. It was asked in 2022. Compute NBHN 2022, last year. Compute this double integral where A is the region xy such that, okay, A is this, I've just drawn for you here. A is this whole disk that we have. And you were asked to, excuse me, find this double integral 3x squared y minus y cubed dx dy over A. How would you proceed? Can you guys tell me any idea? How would you like to proceed with this problem? Which method would you rather use to find this double integral?
So we can do this on polar coordinates.
Exactly. And what are the, okay, tell me how you would substitute.
First I'll take y square common from this, and then substitute it by r.
You would take y square common. Look at the region first. Like if you look at the region, you'll get some clue about how you would like to substitute. Okay, before this, recall how you did. This is our A, right? It is like a shift. You get this this by translating our original unit disk, right? If you translate it in vertically above, you'll get this. So when it was this one, our disk was x squared plus y squared equal to 1 or less than equal to 1. How did we substitute it? It was x equal to r cos theta, y r sin theta, right?
Yes.
Now, how would you apply this idea for this particular disk, which is translation of this unit disk? How would you apply that idea here?
Sir, x equal to r cos theta and y minus 1 equal to r sin theta?
Exactly, that is correct. So because of this translated disk, our x and y, there's a shift, right, in the origin of this, or rather the center of this disk. So I'll make a substitution, x equal to r cos theta, y minus 1 equal to r sin theta. And that is, this is what we have for x, or from here we get y 1 plus r sin theta. And the Jacobian and everything that you find, determinant of del x, del r, del x, del theta, del y, del r, everything will be the same because the only change is this plus 1, and constants don't have any effect when we differentiate it. So it will be Jacobian will be just 1. J is just 1, like, sorry, it's r, I think. J is just r, not 1, r. So if you substitute all these things, x equal to y equal to this in this integral, okay, tell me now the limits of r. What will be the limits of r and the limits of theta for this particular change of variable? Look at this disk and tell me the limits of r and theta. What are the limits of r and what are the limits of theta? This is the center of this disk.
So theta equals to 0 to 2 pi and r equals to 0 to 1.
Exactly, that is correct.
ആശയൊക്കെ കുറച്ച് ദിനെ അങ്ങനെയായി ചെയ്യാൻ തോന്നുന്നു.
So if you make it a function after substituting, you'll get a function. I'll just write function of r and theta because I don't have time. Dr. Achha, maybe after the proper substitution, you'll get a function of r and theta, and the absolute value of the Jacobian. The Jacobian was r. The absolute value of r is just r because r is positive. Dr d theta, and the limits of r are 0 to 1. Theta goes from 0 to 1. Theta 0 to twice pi. So it will be nothing but some function of r and theta. This is r, dr d theta. R going from 0 to 1, theta going from 0 to twice pi. The answer will be just minus pi. You'll get minus pi if you do this calculation. It's a slightly long calculation. There will be many terms here. Is it clear? Guys, is it clear? The solution? Or
how we taken the limits of r and theta?
see, the r was this disk, right? It just look at the region how A is defined. X squared plus y minus 1 squared less than or equal to 1. So it's a disk centered at 0, 1, and it's of radius 1. This is our point 0, 1. 0, 1 is this point. This point is 0, 1. 0, 1, and it has radius 1 because it's less than or equal to 1. That is why we get r going from 0 to 1. Clear?
Okay, sir.
And theta going from 0 to twice pi because it's a complete revolution, right? It's a complete revolution like this. So 0 to twice pi.
Okay, sir.
Right. Yeah, so the last problem. It was asked in 2023 mathematical statistics. Which of the following is true? It's an MSQ question. Max, okay. What happened? Yeah, this last problem. 0 to 1, the function is, there are two functions. The function A is, if you look at the option, e power max, this is this. The function B is e power min, this is this. So max min of x squared y squared. So e power max x squared y squared dx dy. The region is 0 to 1, 0 to 1. 0 to 1, 0 to 1. What is this? This is our first question. The second question is e power min, minimum of x squared y squared dx dy 0 to 1, 0 to 1. How would you do this problem? The region is this. This is the region that we have. The unit square. You have to integrate these two functions. This one, the max, and the min of, e to the power max of this and e to the power min of this over this unit square. How would you take care of it?
So we can again take x is equal to y that means.
The same idea that we did before, right?
Yes.
Yeah, divide it into some number of parts where you can deal with this function max and min, correct? So if you look at this, this line is y equal to x, y equal to x, or x equal to y, and in this region, is it x greater than y or y greater than x?
It's greater than
Greater than y.
Yeah, if x is greater than y, then definitely x squared is greater than y squared, right? And when x squared is greater than y squared, we will have the max and min of this to be the x squared or y squared, depending on which function we are choosing, correct? Likewise, in this region, you'll have these are, I'll call it A2. And here x is less than y, and so x squared is less than y squared in A2. So to find out, I'll just show the solution for this one. You can
Sir,
try. Mm-hmm.
Here x and y are less than 1, no, sir. So x square is less than y square for x greater than y.
No, that works when, yeah, what you're saying, yeah, there is a confusion. Yeah, let me address that one. When x, let me address the confusion that you have. When x lies between 0 and 1, the more you raise the power of x, see, there is only one variable now. The more you raise the power of x, the smaller it will be. So that means if I have m greater than n, then x over m will be less than x power m. This works when there is only one variable, and that variable has value between 0 and 1. Okay? But if you have two variables, even though they lie between 0 and 1, if you raise to the same power, the inequality don't get reversed. For any x squared plus y squared, x cubed is less than y cubed. For any n natural number, this inequality is preserved for any natural number n, even though they lie between 0 and 1. Clear?
Yeah, okay.
Like if you look, like the easiest way, if you forget it, then just look at the square function. Suppose this is 1, 0 to 1. If x is less than y, the x squared is less than y squared, right? The cubic function, all these things work. Okay? Yeah, so I'll just keep it. Now, yeah, max of x squared and y squared. So in this region A1, x squared is greater than y squared because x is greater than y. So I think you get the idea about how to solve this problem. Double integral e power max of x squared and y squared dx dy 0, 1, 0, 1. I'll break it up into two parts. E power max x squared y squared dx dy over a1 first, the one that we have, and the other one would be e power max x squared and y squared dx dy over a2. In the region a1, x squared was greater than y squared, so I'll have the max of x squared and y squared to be just x squared. E power x squared dx dy a1, and in the region a2, the y squared is greater than x squared, so it will be y squared now dx dy a2. Now you take care of, like, say, you can't integrate this function directly with respect to x, so just do the change of order of integration. Here you don't have to change because there's a function of y and there's an x. So take care of all these things like the way we have described, and you'll find that the max for this one, the solution is twice 0 to 1, 0 to 1 will be the limit of y, so limit of x, 0 to y1 e power x squared dx dy. This is option C. Option C is correct for us when it is for the max function. Also, you can check that this value, this option C, right? This option C is correct. And you can compute this easily, and you'll find that this is also equal to twice, no, this is just, I think it's e minus 1. This is just equal to e minus 1. So that is option A is also correct. So A and C are correct options, and B and D are wrong. You can verify that easily. The idea is just to break up this area to take care of the max and min functions. That is it. Any question, guys? Because that was the last problem. Are you guys following this solution?
Yes.
Does anyone have any doubt or anything that you would like to ask? Or in any like problem that we had so far, would you like to ask any question or anything about it? Anyone?
Sir, I'm Neetu from Palakkad. Sir,
Yeah.
thank you for the selection of problems and your valuable time. It was very helpful for us. Thank you,
Thank,
sir.
thank
Thank you. Yes.
Hello, sir. I'm IIT Krishna from Government Victoria College, Palakkad. Your session was very nice, and I got many more ideas to compute this question. And thank you, sir.
Thank you. Thank you so much.
Hi, sir.
Hi, sir. Good afternoon.
Good afternoon.
Sir, the class was really interesting. I really enjoyed this, and I could finish problem with enough time. So, sir, you really helped us to really helped us to cover these problems easily. Thank you for your valuable time, sir.
Thank you so much. Thank you so much.
Yeah.
Hi, sir. I'm Adira from Government Victoria College. It was very interesting class. I got many ideas about solving the problems. Thank you so much, sir. Looking for more sections.
Thank you so much. Thank you so much.
Hello, sir.
Hi.
I am Parvati from St. Teresa's College, Kerala. The session was really helpful. Thank you for giving us such a wonderful session. And special thanks to Vinod sir for holding such sessions. We are hoping to get more sessions in future. Thank you.
Thank you.
Thank you.
Sir, my name is Sharada and I'm from Kerala. Sir, thank you so much for the session, and all your sessions is very clear, sir. Thank you for your time, and thank you, Vinod sir, for organizing the sessions. Thank you, sir. Thank you so much.
Thank you. Thank you so much.
Hi, sir. I'm Ananda from St. Teresa's College at Nagalam. Sir, the session was really nice. You used some problems that was really helpful. Thank you, sir, for this class, and thank you, Vinod, sir, for conducting such a great class.
Thank you so much.
Thank you. Yes.
Hello, sir. I am Ritam, Bardwan Raj College from West Bengal. Thank you, sir, for this amazing class. It's really helpful for me. Thank you.
Thank you so much.
Yeah. Thank you, Ritan. Yes. If any of you, yeah, yes.
Sir, thank you for the class. The problem solving strategies were really great, and it was pretty helpful for us.
Thank you.
Please introduce yourself. Sansudha Mukherjee.
Yes, myself Sanshudha Mukherjee. I'm from Burdwan.
Yeah. West Bengal, right? Yeah.
Yes, sir.
So you are preparing for JAM examination.
Yes, sir.
Okay. All the very best.
Thank you, sir.
Okay. Are you there in our WhatsApp group?
Yes, sir. I'm there.
Okay, that's good.
Hello, sir.
Yeah.
Hi.
I am Praveen from Thrissur. The session was really very interesting and informative. Thank you for the session.
Thank you so much.
Sir, good afternoon, sir.
Yeah.
Good afternoon.
Yes, sir. I'm Kali Sharif from Tamil Nadu. Till now, I thought that integration and the evaluation was so difficult to find, but after
After attending this class, I get some confident about the finding evaluation of integrals. So thank you so much, sir.
Thank you so much. Thank you.
Thank you, Kalishwari. That is the major thing that we are expecting through these type of sessions. You should get a confidence to approach the problems. So very happy that this session helps people to attain that confidence. Yes, if any others would like to share a feedback, please make it now.
Hello, Krishna sir.
Yeah.
Yeah.
Does anyone like philosophy in this class?
Sorry?
Does anyone like philosophy in this class?
Philosophy?
Yes, I just want to say something about it actually.
Yeah, please go ahead.
Actually, I've been through so many phases of life actually. Like whatever you are going to taught us, I am going to execute it in next generation. Like if you taught me villainy, I will execute it. If you taught me good thing, I will execute it in proper way. But what you are doing actually pretty much appreciated. I cannot like literally thanking you like it's okay, thank you, that's all. What kind of like it's literal. But what you are doing, it's actually it will be appreciated.
Okay. Thank you, Sital, for your nice words. Could you introduce yourself? Your which place?
I think we should turn on the camera, right? So that like the rest of us can see you too. Sital?
Yeah,
can you turn on the camera too? Like, or are you in a place where you can't turn on the camera?
I'm in spiritual place. Actually.
Okay. Could you introduce yourself? Your where are you studying currently? Which course?
I'm pursuing masters actually.
Okay.
And planning for CSIR or UGC NET.
Okay. Very good.
Yeah.
See, like Vinod sir does a lot of things for all of us. Like there are so many free sessions. Yeah, even when I was preparing for exam, I took a lot of help from the sessions that were conducted by Vinod sir. And yeah, if you talk about my life too, I was in a bad phase too. Like the COVID time and everything. Everything was closed and everything. No college, nothing. I was very much frustrated. I was even depressed and all those things. Someone suddenly, like out of nowhere, sent me a link for this Maths Aspirants group. That is how I started by joining this group, and it helped me a lot. I remember joining many classes like complex analysis, linear algebra, and metrics. All these things were very helpful for me. So yeah, and I hope that you are getting the same help that I got by attending all these sessions conducted by Vinod sir.
Yes, Vinod sir is everything.
Yeah, like see. These days, there are so many institutes collecting a lot of money, right? But Vinod sir is doing it for free. We are getting like what we are taught at college. Like they usually teach us theorems and proofs. That is all we are we do usually in college. But if you want to crack exams like NAT, GATE, and all NVHN, you have to know how to solve the problems. You have to know how to approach the problems, right? There is whole another thing. You need training for those kind of things, and that you get here in Maths as well for free. That is wonderful.
Thank you, both of you, for your nice words about our group. And actually, apart from these classes, you are getting a good peer group as well in our discussion platform. Okay. Others, if any of you would like to share a feedback, you can make it now. Aditi is here. Vandana is there. Tulya is there.
Hi, sir. Good afternoon. My name is Vandana and I'm from Kerala. First of all, thank you, sir, for this wonderful and interesting session. The methods and the way you presented were so easy and easy to follow. Thank you, sir, for spending your time, and thank you, Vinod, sir, for conducting this session. Thank you.
Thank you so much. Thank you.
Thank you, Vandana. Yes, Aditi.
Afternoon, sir.
Yeah.
Afternoon.
I'm from West Bengal and I'm currently doing my master's in IIT Mumbai. Actually, these questions I have seen previously, but the only thing I learned today is how to approach them. Because in our bachelor's, when we did it, we just like computed and didn't think of it graphically, which I did today.
Okay.
And and I really like the set of questions which you put. Like they were really interesting.
Thank you so much.
Thank you for conducting this session.
And you are studying at ICT Mumbai. What did you mention?
Yes, sir. ICT Mumbai.
Acha, doing your master's in mathematics there.
Yes.
Okay, very good.
Thank you. Thank you, Aditi. Yes. Yes, Krishna, once again, thank you for being with us. And please share the PDF of the questions with workout if possible. We can share it with the recorded video. Maybe useful for the students.
Yes, sir. Yeah, I'll share it by today evening. Does it work, sir?
Okay, that's enough.
Okay, sir.
So let us wind up here. Once again, wish you all the very success in your career, Krishna. All the very best. Thank you.
Thank you so much.
Yeah.